Hello, hi. So moving on to the next question. Consider the following circuit. So the circuit is given and they are asking you to, in this circuit, if race around condition is present or not. So first, let's just understand what is race around condition. So race around condition is a condition basically when our clock is having a large number of duration. Okay, when it's having a large number of duration, when it's on, when its value is 1, right, and output is changing in between multiple times, right? So race around condition generally occurs in JK flip-flop. It occurs in JK flip-flop. As if you remember, in JK flip-flop, if I draw the excitation table, so when J and K both are 0, its value is past value. But when 1 is there, what happened? Its value will toggle. So what happened? JK flip-flop is active when clock is equals to 1 and it's a level triggered flip-flop. So when the clock remains at 1, the output will toggle again and again and it will become unstable. Right? If clock is larger, have larger duration as compared to the output, then what happens? Till the time clock is on, when the clock value is 1, its condition is clock value is 1, since it is a level triggered. So there are two types of triggering when we talk about clock. One is this edge triggering and one is this level triggering. Right? Whenever the complete level will remain 1, this flip-flop will remain in active state. Right? When clock is 1 and J K value both equal to 1. So this is the condition for race around. Right? Now, if you see this flip-flop, this diagram, so this is not a JK flip-flop. Since JK flip-flop is connected somewhat like this. Right? This is the circuit diagram for JK flip-flop. So previous one is the circuit for SR flip-flop. So there is no such race around condition is present in SR flip-flop. So this is my SR flip-flop. So race around condition does not occur in this particular circuit. So you have to remember the circuits for flip-flop also. So this is how SR flip-flop while implementing it with NAND gate looks like. Okay, right. Moving on to the next question. Two D flip-flops are connected as a synchronous counter that goes through the following QB and QA sequence. So that sequence is given. So first in after this first value of input is this, then it switched to next state, then next and next. They are asking the combination of the input DA and DBR. So from the options we have to give the value. So it's easy, right? All the states, the previous state and the next state is given to us. So if the sequence follows something like this, so this become previous state, this become next state, right? For first clock. For second clock, this become previous state and this become next state and so on. So like this sequence is moving and we are using D flip-flop. As we know, D flip-flop is transparent flip-flop, synchronous is there. So all the movements are simultaneous, right? So you can say that I can write that previous state, next state, and the values of inputs. Input are nothing but DA and DB. So values of previous state QB, QA, QB, QA, next states, and input DB, DA accordingly. So how the sequence is moving from 0, 0 to 1, 1. So inputs will become 1, 1. From 1, 1 to 0, 1. So inputs will become 0, 1. From 0, 1 to 1, 0. So inputs will become 1, 0. And again from 1, 0 to 0, 0. So inputs are 0, 0. And after this, it will repeat itself again and again. So this is the sequence. Now they are asking us to find out the values for DB and DA with respect to QA and QB. So we can easily draw a Q map from this in order to find it out. So if I draw K map for DA, since it's just 2-bit, QA, QB, QB bar, QB, QA bar, QA. So it is present for DA, DA we are talking about. So it is 1 for 0, 0, that is 0th value, and it is 1 for 4, right? Third. This is 0, 1, 2, 3. So it is 1 for this and 1 for this. So value for DA will become, so this block is 1. So it is QA bar, QB plus, also this block is 1. So that is QA, QB. So this is the value for DA. Similarly, we can make a K map for DB here. Same values are there. I'm just making it for DB. So DB is 1 for 0 and again 1 for 1. So 1 and 1. So this is what? QA bar. DB is equals to QA bar. Which option satisfies it? 0 and 1, right? 0, 1, 2 and 3. Zero, 0, 0, 1. QB is our MSB bit, right? So QB should be here. So little mistake. QB should be here, QA should be here, because we write MSB here. So accordingly, so this will become right. In this, if you see, these are 0, 0. So 0, 0 will be present here. But this is 0, 1. So QB value is 0 and QA value is 1. So QB value should be 0 and QA value, this is QA, this is QB, sorry. This is QA, QB, QB bar, QB, QA bar and QA. So it represents QB value is 0. So QB value is 0, that means it will come here, right? So in this case, this will become DA, so DB. So that is not QA, not QA, but QB bar. Understood? What is this? There was some confusion because I have represented this is MSB and this is LSB. So it should be represented like that only, right? So this is 0, 0. It's okay. 0, 0 is when QA and QB bar. So 0, 0 means nothing but, let me write it like this. You can simplify it because this is nothing but a 2-bit thing. So you can simplify it directly also. You don't need any K-map to solve it. So if you write it directly here, so this is what? QB bar, QA bar, QB, QA, QB bar and QA, this is QB and QA bar, right? So this DA is 1, 1 for this value and this value. It's okay, so we have written it, and DB is 1 for this value as well as this value. From this, if we take, so this is QB, QA bar plus QB bar, QA. So if I take QB bar common, so it will become QA plus QA bar. So this will become 1 and it is eventually QB bar. Right, instead of solving from K-map, we can solve it directly also, but K-maps are also easy. There was a confusion because I wrote, I took a QA as MSB, but by taking QB as MSB, we can see that the value of K-map will also become QB bar. Okay. Okay, moving on to the next question. Okay, so next question says that when the output Y in the circuit below is 1, it implies that the data has, what are the options from the 4 options? Change from 0 to 1, change from 1 to 0, change in either direction, not change at all. So what they are saying is this become 1. And this is what type of gate represented here? AND gate. This is your AND gate. So when output is becoming 1 in an AND gate, that means both the inputs should be 1. Only when both the inputs are 1, only in that case the value of output of AND gate will become 1, right? So that means the value of this should be 1 and the value of this should be 1. Got it? Now they are saying that what should be the value of data change? That the data is changing from what to what? Suppose data was 0 first. If my data bit, my clock data, let me write it Q1 and let me write it Q2. Q1 and Q2, right? For first clock, if I am saying data was equals to 0, suppose data was equals to 0, then what happened in this clock? Q1 will become 0, Q1 will become 0, but this will become 1, this will become 1 and this will become 1 in next clock only. So this is not known. For in second clock, if I am saying data is making 1, data is value is changed from 0 to 1. Now in second clock, what will happen? This 1 will shift to here and this Q2 will become 1. This Q2 will become 1 and also data is moved from this 0, from 0 to it, from 0, it was 0 before and it became 1 now. Now it will give Q1 also as 1, Q1 as also as 1. So in this case, we are getting both Q1 and Q2 as 1. Since we are getting Q1 and Q2 as 1 in this particular case, the output will become 1, right? So what is the transition of data? Transition of data should be from 0 to 1, right? What happened if I take the other case? For example, in first clock, if I take data is equals to 1, so Q1 will become 1, right? And this Q bar will become 0. So 0 will be transited from this Q1 bar to Q2 bar, right? 0 will be transmitted because 0 will be connected to D and whatever the value of D, that will be reflected to the output of the D flip-flop, right? So it will become 0 in next clock. Whether I am making it 1 also, if it is 1 also, it will become 1 and 0, right? If I make it 0, it will become 0 and 0. So what is the transition needed? The transition change from 0 to 1. So this is the required transition. Understood? This is an AND gate, right? Output is 1. That is given to us and they are asking what is the transition that is occurring in data. So this is not a condition, this is not a condition, that is not changed at all. This should be changed. And what is the desired change in order to make both the Q1 and Q2 value 1? So change should be from 0 to 1, right? Okay, moving on to the next question. Assuming that the flip-flop are in reset condition initially, the count sequence observed at QA in the circuit. So they are saying that you have to again check which of the sequence is true regarding to this flip-flop. Easy, we have done this kind of question before also. We have to make the table. Okay. As we can see, this is shifting. And DA bit is given by QB, XOR, QC, right? And we can see that DB is nothing but QA and DC is nothing but QB, right? From this we can make the table and easily see that what is the transition which is occurring here. So I'm making table here. This is the only space I can see. Okay. So what are the values? We have to take the values. This is, I'm writing clock first. And these are the values of DA, DB and DC with each and every clock, and this is output Y. And they are asking what is the value of output. Their output is nothing but, we have to check the value for QA, that will be same as the value of DA. This is the D flip-flop, transparent flip-flop. Whatever the value of DA will be, that same value will be reflected at the output, that is QA. Right, this is what we require. So that means sequence of DA is required. Let's say clock 0, they are all reset. Okay, what's the value of Y will become? Y is nothing but QB XOR QC. So DB XOR DC value we have to take as XOR. XOR gate table, you know. So XOR gate truth table also I am drawing here. So what's XOR gate truth table? So input 0 0. I'm directly drawing it rather than writing input output. 0 1 1 0 1 1. So it's 0 1 1 and 0. When the inputs are different, the value of output of the XOR gate will become 1, and the values are same, it will become 0. Now nothing left in this question, just solve it and we will know. And what's happening? It is shifting. So there is no last shift is there. The shifting is happening. So this is what's happening in clockwise sequence, and this Y will come to DA. Now Y value will become 0 0 is equal to 0. So in next clock 0 will shift. So 0 0 0. This is XOR gate only, right? Assuming that the flip-flop are in reset condition initially. Okay, and the count sequence observed at QA in the circuit is shown, and clock is given as same, and they are moving like this. Right, so what's happening in next clock? Again this is 0 0, and what will happen? The output of XOR gate will become 0. Wait, there is some, this is a mistake here. This is not XOR, this is XNOR gate actually, right? This is XNOR gate, because if I take XOR gate, the value will always be 0 0 0 and it won't work like that. So this is XNOR gate. So now let's just try to solve this. Okay. This is XNOR operation which is happening here, because otherwise it will just move from 0 0 to 0 0 again and again, so there will be no sequence present. So this is XNOR gate, right? Or you can say that this is a not present, right? So this not is connected here. Either way you can see this, but there is no specific mention of this not, so I am just assuming it that this is a not present here. Otherwise it is just XOR gate only, because otherwise it is not possible to make it. Right, now you see 0 0 will become 1, right? Moving on, this this 1 will move here, and these 0 and 0 will move here and here. Again it will become 1 0 0 XNOR. The next one in second clock, this 1 will come here, 1 will come here, and it's 0. So XNOR table also I write. So XNOR table is just opposite of XOR. This is XNOR table. So it is 1 0 0 and 1. Right, for 1 0 it will become 0. In third clock, what's happening? 0 1 1. For 1 1 it is again becoming 0. In fourth clock, what's happening? 0 0 and 1. It's becoming 1 in fifth clock, right? So it's 1 0 0. It's again becoming 0. It's again becoming 1. They are not like, so it will be 0, right? So 0 0 0. Now it's repeating itself again and again. So it was 1 here, it is 0, and it repeats itself again and again. So it starts from, this is your sequence. One and 0. So this is your sequence 0 1 1 0 1 0. So which option is correct? 0 1 1 0 1 0. So this is your correct option, right? We have to observe the sequence for DA. This is your DA, or you can say observe the sequence for QA. This is your QA only. Great. What was there in the question? It was very easy question, but the confusion happened here because of this gate. Okay, this must be XNOR gate. Okay, this is XNOR gate present here. So this is the operation where that is happening. Output is equals to, we have to find out the sequence for value of output of DA flip-flop, that will be QA. Right, operation happening is XNOR. What we have to do, just make the table, and these values are shifting. So shift according to that. This Y will become value of DA. So we are solving it 0 0 0 because they have said that reset condition. So reset condition means all 0. Reset condition means all 0. Right, so all zeros were there. 0 0 will become 1. 1 will shift at DA, and these two will shift like this. 0 0 is again 1. 1 will shift here, and these two will shift here. Now 1 0 is 0. 0 will shift here, and these ones will shift here. 1 1 is again 1. 1 will shift here, and 0 1 will shift like this. This 0 1 is again 0. So 0 is this, and this is 1 and 0, and it will go on like this. This will again become 0, 6th clock, right? So 0 0 and 1 again becomes 0, 7th clock, 0 0 and 0. Now after this, the transition will complete, right? So this will become your sequence. So this is the sequence they were asking for: 0 1 1 0 1 0 0 and 0, and so on.